According to the National Electrical Code, specifically Chapter 300 regarding wiring methods and materials, cables are prohibited from being installed inside ductwork. NEC Section 300.22c states that conductors in ducts, hollow spaces, or cable trays shall not be subject to physical damage. Furthermore, NEC Section 300.11 mandates that conductors exposed to different temperatures within the same equipment must be protected from thermal damage through dirting or other suitable means. Running cables through ductwork is not a common or acceptable practice and is generally considered a code violation. While older buildings might contain existing installations that do not adhere to current code standards, this does not justify repeating the error. In your specific situation, it is not permissible to run the cable for the new exhaust fan through the ductwork. Instead, you should penetrate the roof using rigid metal conduit, commonly referred to as RMC, and then transition to Liquidtite flexible metal conduit. This method guarantees that the installation complies with code requirements and provides sufficient protection for the cable. There are several safety concerns associated with running cables through ductwork. Firstly, physical damage. Cables can be damaged by repeated exposure to heat and vibration within the ductwork. Secondly, thermal damage. Cables can overheat due to the elevated temperatures inside the ductwork. Thirdly, fire hazard. Damaged or overheated cables can become a fire hazard. It is highly recommended to follow your foreman's instructions and install the new exhaust fan using RMC and Liquidtite flexible metal conduit. This ensures a safe and code-compliant installation. The reasons for these code requirements are multifaceted and center on safety and the longevity of the electrical system. Ductwork is designed for airflow, not for housing electrical cables. Introducing cables into this environment creates several potential problems. Physical damage is a significant concern. Ductwork is often subject to vibrations from the HVAC equipment it serves. These vibrations can cause the cable insulation to wear down over time, exposing the conductors. Additionally, the sharp edges and corners inside the ductwork can chafe and damage the cable. Once the insulation is compromised, the risk of short circuits and electrical faults increases dramatically. Thermal damage is another critical factor. Ducts can experience significant temperature fluctuations, especially in areas with extreme climates. High temperatures can degrade the cable insulation, reducing its effectiveness and lifespan. This degradation can lead to premature failure of the cable and increase the risk of electrical fires. The NEC addresses this issue in Section 300.11 by requiring protection against thermal damage. Fire hazard is perhaps the most severe consequence. If a cable running through ductwork becomes damaged or overheated, it can ignite flammable materials present in the duct or surrounding areas. Dust, lint, and other debris commonly accumulate in ductwork, providing fuel for a fire. Moreover, the ductwork itself can act as a chimney, spreading the fire rapidly throughout the building. Using RMC and Liquidtite flexible metal conduit offers several advantages over running cable directly through ductwork. RMC provides a robust, grounded enclosure for the conductors, protecting them from physical damage and minimizing the risk of electrical shock. It is also resistant to fire and high temperatures, offering an additional layer of safety. Liquidtite flexible metal conduit allows for movement and flexibility, accommodating any vibrations or shifts in the building structure. It is also waterproof, preventing moisture from entering the conduit and damaging the conductors. The transition from RMC to Liquidtite flexible metal conduit is typically made at the point where the conduit enters the equipment or appliance. This transition allows for easy connection and disconnection of the equipment for maintenance or replacement. When installing RMC, it is essential to follow all applicable code requirements, including proper grounding and bonding. Grounding ensures that any fault current will safely return to the source, tripping the circuit breaker and preventing electrical shock. Bonding connects all metallic parts of the electrical system together, creating a low impedance path for fault current. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations. It is crucial to consult with your local building department or a qualified electrical inspector to ensure that your installation complies with all applicable requirements. The recommendation to use RMC and Liquidtite flexible metal conduit is not just about code compliance, it is about ensuring the safety and reliability of the electrical system. By following these guidelines, you can minimize the risk of electrical hazards and protect the building and its occupants. Always prioritize safety and consult with qualified professionals when working with electricity. Ignoring code requirements and safety guidelines can have serious consequences, including electrical shock, fire, and property damage. Remember that electrical work should only be performed by qualified and licensed electricians. These professionals have the training and experience necessary to safely and effectively install and maintain electrical systems. Attempting to perform electrical work without the proper knowledge and skills can be dangerous and may violate local codes. When in doubt, always consult with a qualified electrician. They can provide expert advice and guidance to ensure that your electrical installation is safe, reliable, and code compliant. In summary, running electrical cable through ductwork is a code violation and a safety hazard. The NEC prohibits this practice due to concerns about physical damage, thermal damage, and fire hazards. The recommended installation method is to penetrate the roof with RMC and transition to Liquidtite flexible metal conduit. This approach provides superior protection for the conductors and ensures compliance with all applicable codes and regulations. Always prioritize safety and consult with qualified professionals when working with electricity. Understanding the specific sections of the National Electrical Code that pertain to wiring methods in ducts and plenums is crucial for ensuring safety and code compliance. As previously mentioned, Section 300.22c is the primary reference point. This section addresses wiring in ducts used for dust, loose stock, or vapor removal, and it strictly prohibits the installation of wiring systems within such duct. The rationale behind this prohibition is that these ducts often contain combustible materials, and any electrical fault or overheating could easily ignite a fire. Furthermore, the accumulation of dust and debris within these ducts can further exacerbate the fire risk. When working with electrical installations in or near ductwork, it is also essential to consider the requirements outlined in other sections of the NEC, such as those related to grounding, bonding, and overcurrent protection. Proper grounding and bonding are critical for minimizing the risk of electrical shock and ensuring the fault currents can safely return to the source, tripping the circuit breaker and energizing the circuit. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring from overheating and potential fire hazards. These devices must be properly sized and installed to effectively interrupt the circuit in the event of an overcurrent condition. In addition to the specific requirements outlined in the NEC, it is also important to follow general best practices for electrical safety. This includes using appropriate personal protective equipment such as gloves and safety glasses, and ensuring that all electrical equipment is properly maintained and inspected. Regular inspections can help identify potential problems before they become serious hazards. Moreover, it is essential to stay up to date on the latest changes to the NEC and other applicable codes and regulations. The electrical industry is constantly evolving, and new technologies and best practices are continually being developed. By staying informed, you can ensure that your electrical installations are safe, reliable, and code compliant. When faced with a situation where you are unsure about the proper way to install electrical wiring, it is always best to err on the side of caution and consult with a qualified electrical inspector or engineer. These professionals can provide expert guidance and help you navigate the complexities of the electrical code. Remember that electrical safety is everyone's responsibility, and by working together, we can create a safer environment for ourselves and others. Following the NEC guidelines for installing electrical wiring near ductwork involves several key steps. Firstly, identify the type of ductwork. The NEC distinguishes between ducts used for environmental air and those used for dust, stock, or vapor removal. Different rules apply to each type. Secondly, avoid running cables within ducts used for dust, stock, or vapor removal. This is strictly prohibited. Thirdly, for ducts used for environmental air, wiring methods must be suitable for the environment. This typically means using metal conduit or cable with a metal jacket. Fourthly, support wiring properly. Wiring must be securely supported to prevent strain on connections and to avoid contact with ductwork. Fifthly, ensure proper grounding and bonding. All metal components must be properly grounded and bonded to minimize the risk of electrical shock. Sixthly, inspect the installation. After completing the installation, thoroughly inspect it to ensure compliance with all applicable codes and regulations. Consider alternative wiring routes. If possible, reroute the wiring to avoid running it near ductwork altogether. This is often the safest and most cost-effective solution. Also, use appropriate connectors and fittings. All connectors and fittings must be listed for the intended use and properly installed. Moreover, protect wiring from physical damage. Wiring must be protected from physical damage, such as from sharp edges or moving parts. When dealing with existing installations, it is essential to assess the condition of the wiring and ductwork. Look for signs of damage, such as cracked insulation, corrosion, or loose connections. If any damage is found, it should be repaired or replaced immediately. Additionally, it is important to verify that the existing installation complies with current code requirements. If it does not, it should be brought up to code as soon as possible. When making any changes to an existing electrical installation, it is crucial to obtain the necessary permits and approvals from the local building department. This will ensure that the work is performed safely and in accordance with applicable codes and regulations. Finally, remember that electrical work can be dangerous, and it should only be performed by qualified and licensed electricians. If you are not comfortable working with electricity, it is best to leave it to the professionals. By following these guidelines, you can minimize the risk of electrical hazards and ensure that your electrical installations are safe, reliable, and code compliant. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. The goal is to ensure that the electrical installation for the exhaust fan meets all safety standards and complies with the National Electrical Code. Using RMC, rigid metal conduit offers physical protection to the wiring as it passes through the roof. The transition to Liquidtite flexible metal conduit, often called Liquidtite, allows for flexibility and vibration dampening, especially near the fan motor. Direct burial rated cable is intended for underground use and is resistant to moisture and physical damage. However, it is not typically used inside buildings or ductwork because it lacks the fire resistance properties required for indoor wiring. Conduit fill refers to the amount of space inside a conduit that is occupied by conductors. The NEC specifies maximum conduit fill percentages to prevent overheating and to allow for easy wire pulling. The NEC, or National Electrical Code, is a set of standards for safe electrical installation and maintenance. It is updated every 3 years and is widely adopted throughout the United States. Local jurisdictions may also have their own electrical codes, which may be more stringent than the NEC. Always check with your local building department to determine the applicable codes and regulations. Licensed electricians are required to have extensive training and experience in electrical work. They must pass a licensing exam to demonstrate their knowledge of the NEC and other applicable codes. Hiring a licensed electrician ensures that the work will be performed safely and in accordance with all applicable requirements. Electrical permits are required for most electrical work, including the installation of new circuits, the replacement of electrical equipment, and the alteration of existing wiring. Permits are typically obtained from the local building department. They allow the building department to inspect the work and ensure that it complies with code requirements.